We have to get used to this relational terminology before we get into the data model. See, there are various terms which will be new to you. What I try to do is I'll try to put them in correspondence with some other terms so that it will be easy for you to remember. But strictly speaking, you should use only these terms in this relation model. But to make it easy for you, what I found out is whenever I use these terms, it will be difficult for it is generally difficult for students to immediately recollect what the concept is. So what I try to do is I map them to some other terms, but I shouldn't be doing that. I do it because it will be easy for you, right? So you try to remember these terms, and I'll also give you alternate terms which I'll use, and whenever you write it in the exam, you should be able to do that mapping from the informal terms we are going to use and the formal terms the model is going to use. Informal terms I use because it will be easy for you to understand, okay, but formal terms will be given in the exam, okay. Just be careful with that. Let's see this. So the first term in the relation this relational model is the term relation itself. So relation, you can think of it as a table informally. Formally, even though it is a relation, informally you can think of it as a table. So what is a relation? It is simply a table, right? Now what will table have? Table is going to have if you think of it like this, table is going to have various rows and various columns, isn't it? Rows and columns, right? Therefore the simple term to remember relation is, you can think of it as a table, right? And what about a tuple? A row is called a tuple, right? So tuple is nothing but one particular row. What is the significance of a row is, it actually represents, if you remember that ER model, every row in a relation model represents a entity or relationship in the ER model, right? So if you talk about one row, it will completely describe one entity. Let us say student entity. If student is having name, roll number, marks, everything, one row is going to give you complete information about the student. Therefore a tuple is actually an entity in the ER model, right? So you can think of this tuple as a row. So instead of using this relation and then tuple names, I will sometimes use table and row to make the things clear, okay? And an attribute is a column, okay? So this entire one column, you can think of it as an attribute, right? So table is a relation and tuple is a row and attribute is a column, right? And the domain is generally domain means a set of values. Let us say domain is set of names. Domain is generally a set of values, right? So there are various domains possible, and every attribute is going to be associated with a domain. For example, you can say that this particular attribute is having domain integer. So what does it mean? All the values which can be present in this column should always be integers, right? So domain is associated with attribute itself, right? So in a simple word, meaning of a domain is, and the easier way to remember what a domain is, you can think of it as set of values, okay? For example, set of integers or set of names or set of characters, anything. So domain is generally a set of values, and we generally assume that it is finite. So domains, if you think of it in general sense, domain should not be finite, but when we think about it here in especially this model, we say that a domain is, or we assume that the domain is finite. It has got some implications. We shall see what is the implication of this later. And next one is relation schema. So relation schema means the heading of the table, right? So generally every table will have a name. Let us say the name of the table is R, right? And every domain is also going to have a name, right? Every attribute is going to have a name, like A1, A2, A3, A4, let us say A5, right? Now we have how to represent this entire table heading is, you can represent it this way, or A1, A2, A3, A4, A5, right? So this entire thing can be called as relation schema, right? So relation schema is nothing but heading of the table. You can imagine it that way, right? And then each each attribute is going to have a domain, right? Let us say D1, right? D2, D3, D4, D5. Let us say these are the domains associated with these attributes, and sometimes two or more attributes can have the same domain, right? But then their attribute names will be different. Maybe you can think of it this way, right? Let us say we have phone number and maybe we have address, and address is a door number. Now phone number and door number both are integers, therefore two attributes can have the same domain, but then they have different names, right? So now the reason why this is actually called as a relation is there is a deep meaning in it. Actually it is all derived from mathematics, especially the set theory. It is all a formal notation, okay? So you can think of it this way. See, now A1 is nothing but a set of all. A1 can take any values from D1, isn't it? And A2 can take any values from D2, and A3 can take any values from D3. All these are set of values, and all these are attributes, and in any particular row we are going to pick one value from this, one value from this, one value from this, one value from this, and one value from this in order to make it a tuple, right? Therefore you can imagine, or any row, right? Or you can imagine, first of all, a cross product of all this Cartesian product D1, D2, D3, D4, D5. If you take a Cartesian product of all this, what do you get? An ordered pair which is containing one value from all of this, isn't it? Now a relation, which means a table, can be imagined as smaller represents a table which is having the heading capital R. You can think of it as a subset of this. Are you following it? Any table is a subset of Cartesian product, and in mathematics any subset of a cross product or Cartesian product is generally called a relation, right? That is why it is meaningful that they are calling this table as a relation, because it is actually a subset of Cartesian product. And how many elements are possible? The number of elements that can be possible in this relation will be as big as the number of total elements possible, isn't it? Then how many total elements can be possible? That depends on the cardinality of each set, right? So let us say the cardinality is represented by like this, right? Then how many elements will be possible? How many rows will be possible in the worst case? As many as, you can think of it this way, right? If the cardinality of this one is 10, 10, 10, 10, 10, then 10 power 5 rows are possible with all these combinations, and all those rows can be present in your table, right? But at practice, even though we have lots of possibilities, every possibility doesn't make a meaningful tuple, which means doesn't represent a meaningful. Let us say a student might not have all possible phone numbers, isn't it? Therefore, even though this one is going to give you a very large number of tuples, in our relation we are going to have at any time only a finite number of tuples, and that is also called as state of the relation table. State means what are the elements that we are going to have in our table at this time. So the number of elements or the elements present in this table at any given point of time is called the current state or state of the relation table at that time. Got it? And next one is yes, relation schema means the heading. You understood that, right? And next one is degree of a relation. So degree of a relation means you can think of it this way: the number of if you look at this columns, the number of columns you can call it as relation straight away, or the number of attributes, right? So the degree of a relationship is not relationship, it is relation. See, relationship is different and relation is different, okay? So the degree of a relation is the number of attributes I have in the table is called relation, degree of the relation, right? And next one is relation state. So the relation state or the current relation state both mean the same thing, which means the table itself. And intention, sometimes the relation schema is also called as relation intention, right? So intention means the heading, schema only. So the relation schema is also called as relation intention. And relation extension means the table itself. Got it? So these are the various terms which we are going to have. So just not to have any confusion, and to make it clear, whenever there is a term relation, I use the term table, and whenever there is a term let us say tuple, I use the term row, right? So with this you should not be getting confused. I hope that you understood these concepts, and I know instead of these names I'll use the informal names. Okay, so we have still some more things to understand before we get into the relational model itself. Okay, I'll tell you all those.